Hi, and welcome to Always Eclectic Stacy. Today we're in our Always Eclectic Chemistry series where you learn chemistry concepts and get your mind bonded. Today we're talking about metallic alloys. Ready, set, let's go. Hi everybody. Today we're talking about metallic alloys, what they are, and how they bond. Here we go. So, here's some really key vocabulary for metallic alloys. First is an alloy. It is a mixture of metals or a metal with a non-metal to improve properties. And then there's several different types of alloys, and we're going to just get into that, but let's talk about what a substitutional alloy is. It's an alloy where one metal replaces another's atoms, and an interstitial alloy is an alloy where small atoms fit into the spaces between metal atoms, and this is because of our lattice structures. Malleability is the ability to be shaped without breaking, and ductility is the ability to be stretched into thin wires. Corrosion, this is the gradual destruction of metals, and a good example of this would be rusting. We have melting point is the temperature at which a metal melts. Durability is the resistance to wear and damage. Electroplating is coating a metal using electricity, and powder metallurgy is making alloys by pressing and heating the different metal powders. So let's talk about the four main types of alloys we might see. But first is, what are they? An alloy is a mixture of two or more elements, where at least one is a metal. They improve strength, durability, and other properties of pure metals. So we're talking about alloys versus a pure metal. Alloys are going to be stronger and more resistant to rust and corrosion. They're going to almost always be lighter and or more flexible, and they are better electrical and thermal conductors, as well as they are less expensive. There are four main types of alloys, and there's a fifth one we're going to talk about that is a mixture of these. So we have a substitutional alloy, an interstitial alloy, we have a homogeneous alloy, and a heterogeneous alloy. So let's get into this. A substitutional alloy is where some of the atoms in the original metal are completely replaced by atoms of a different element. They have to be of similar size. So if it's a big metal, it's going to be also replaced by a big metal, or if it's a small metal, it has to be replaced by a small metal. And a good example of this is brass, where it's a mixture of both zinc and copper. And you can see in these pictures here where the pure metals are all of one type, and you can see where the substitution is happening with those purple dots. We have another alloy type, which is called an interstitial alloy, and this is using your crystalline structure and the space between to make it even stronger. This is where small atoms like carbon fit between the metal atoms in the lattice structure. And a good example of this is when carbon atoms fit between iron atoms, which make it stronger. And this is what we get to see in steel. So you can see in the pictures, the pure metal is still all the red dots, but with the interstitial alloy, those little green dots are the carbon, and it's making its way into the lattice structure to kind of bolster it and make it stronger. Then we have substitutional and an interstitial alloy, where it's a mixture of the two. This is an alloy where both you're exchanging atoms of similar sizes, as well as the small atoms are going to go in and support the lattice structure. And a good example of this is stainless steel, where iron is substituted for chromium and nickel, while carbon moves into that interstitial space. Two other types of alloys, or not types, but like viewpoints of alloys, are a homogeneous alloy, which is a uniform mixture where atoms are evenly spread. A brass is a very good example of this. And you can see it's an even distribution of particles. It's going to be really smooth, versus a heterogeneous alloy, which is a non-uniform mixture with different metal clusters. You're going to be able to almost feel the metal pieces in it. And a good example of this is going to be cast iron or perlite. So let's talk about some common alloys and some of their key properties. So we have brass, which is a mixture of copper and zinc, and it's very malleable. It's corrosion, and it's really resistant to corrosion. And we use this in musical instruments and plumbing. We have bronze, which is copper and mixed with tin. It's strong and still very resistant to corrosion, and it's used in metals like from the Olympics, statues, and ship propellers. You have steel, which is iron and carbon. You have it is strong, hard, and very, but it does rust very easily. This is used in buildings, bridges, and different types of tools. We have stainless steel, which is iron, carbon, and chromium, and it's rust resistant, tough, and strong, and it's used a lot in cutlery, medical tools, and appliances. You have sterling silver, which is copper and silver, and it's more durable and resistant than other regular silver, and it's used in your jewelry and your silverware. And then you finally have titanium alloys, which is titanium mixed with either aluminum or vanadium. It's lightweight, very strong, and very corrosion resistant. It's used in a lot of aircrafts and your medical implants like your knee and hip joints. Then we have some properties, and we talked about some of these earlier. So hardness is the resistance to scratching or denting. Malleability, which can be hammered into sheets. We have ductility, which means it can be stretched into wires. So think of like copper wire and electrical wiring. It's corrosion resistance, which will resist rusting or tarnishing. Then you have density, which is really important because things that are more dense means that they might be more protective, and this is mass per unit volume. And then, so mass over volume. And electrical conductivity is the ability to carry electricity. Finally, how are alloys made? So you might melt them together, and that's in their molten or liquid forms, and that's going to be fusion. You might press and heat metal powders, and that's powder metallurgy. And you might use some electroplating, which is coating a metal with another metal using electricity. Thank you so much about learning about alloys with me today. If you like this video or my content, please do not forget to like and subscribe and check out my other videos. Thank you so much. Have a great day.